killing my camera, but if you just want to see how I look, maybe that has some factor in how you decide what you want to do next, then here is me. And I make sure that I'm always formally dressed when I'm teaching. You should also make sure you're formally dressed when you're learning. It gets you on schedule. Okay. Now, a lot of people are still going to be joining step by step, so keep admitting if they join. But today's session is on version control, Python, and Cursor 101. We're going to see Cursor and see how we can use it. If you don't know anything about Cursor, perfect, this is a session for you. And we're going to start from as low as possible or as simple as possible. Now, some etiquettes, you can ask questions in between, the best way is to raise your hand. And all you have to do is to sit on your chair and just show your hand like this, and I'll know that you're asking me a question. Is it clear? And how do we ask questions? Just raise your hand. You will see a small icon on the bottom of the screen. Perfect. And if your question is answered, then just click it again and your hand will be down automatically. Right? It's a digital version of you raising your hand. Okay. And I can lower all also because I've answered all the questions. So today's session is on version control, Python 101, and Cursor. We're going to cover enough basics to make sure that we understand what Python is and how do we use it, and what are the modules and different things that are associated with it, as well as what is version control, why do we need it, how do we use it, and lastly the cursor part. Cursor part I'll introduce in between also to make sure that you get a good feel of how modern programming is done. Now it is possible for one person to actually create a whole end-to-end software. 30 days with Cursor is a lot, and you can actually potentially build something magical also. In fact, we'll build a small Chrome plugin also just to give you a feel of how it actually works around. Okay, now let's start with version control. Now, what is version control? Now, version control is built on Git, but we'll talk about version control first. And the way we're going to talk about is this. Let's say you have a file and you added some content to it. This file can be a text file. It can be the Python file. It can be a C file. It can be a Blender file, which is a 3D animation software. It can be your doc file, which is Microsoft Word. It can be an Excel sheet, anything. Okay, so imagine any file. You made a change to it. Next day you woke up, you made a change again, but this change was done after you had a fight with your wife or your husband. Then the kind of changes you made were really bad, but you continued. And then after 4 days, you realize, oh, there's something that I have here, and I don't seem to be able to get that content back, and you don't have time, or maybe you've made such a big mistake that now whatever you've done is all gone. That's version control. To solve that particular problem is what we use version control for. So version control allows you to save changes for any file that exists on Earth at every step, and you have to do some stuff manually. Again, it's not free of cost, so you have to involve yourself in doing something, but that's essentially the idea, that every single stage you can actually host and you can go back to it. In fact, programmers love it because what they can do is, let's say we have a version and then you came up with an idea. Okay, imagine this is a bulb, LED bulb, because we are energy conscious now. So we have an idea, but if you implement that idea in your main code or in your main file, that may disturb it something. So you can actually create a branch and continue with that idea. And only when you think the idea is good, you can actually link it back. This is useful for a new programmer that is joining your team also. Or maybe you're a new programmer and you're adding some stuff that may actually break the main functionality. So you can actually test your whole code base or your file or anything you're working on separately. And if it passes all the tests and conditions and the overall general file structure that your organization may be following, then and only then we can actually merge it. So Git is literally a lifesaver. Now thousands of people can work together, but I can't tell you how much Git I use myself. I'm alone, and not alone as in like in life, but when I'm programming, I'm alone. And when I program, I make sure that I do Git every time, especially when I'm working with Cursor, because it changes so much of the stuff that it's very, very difficult to figure out what actually has changed. And if you think what is Cursor and you don't know about it, don't worry. Imagine it's an AI that we are going to be using to make some things, and we'll see a demo of that also. But all of this version control is made enabled by this thing called Git. Now, Git is open source, but of course, when things are open, people make money on it, and that's what GitHub is doing. So GitHub is based on Git. Git is free and open source. You can install Git on your system, and everybody install Gits on the system because That's the best platform that's there. And once you install it, you have to write some line of code, and after that, everything just works for us. And I'm going to show that to you also. So first of all, Git is a small thing, a small software sitting on your system. When you enable it, it acts like a server, which tracks every single file that you actually change and what change was done. You have to specify your own comments to it, that this is why I changed that file. We're going to do that exercise as well. So Git is something that we're going to be using for our version control. Now, version control is a software tool that helps developer manage and track changes to their code base or any other file also. I'll show you any file actually. Now, as a developer or people working on anything, it can be a Photoshop files also. You create things, then you save them, and then we have to change it because we don't like the last file, or a client said something else, or you've forgotten something. Then we save them again, we make corrections again, we save them again, and so on and so on. So every single time that we save, we do not have any idea of how do we go back to the history. Now, we do have versions that we can save in our documents, but that's not powerful enough. And if they are actually becoming powerful, they're actually going to be using Git only, because this is the ultimate of how we manage files. So we need a version control system because it traces and manages changes. So not only you know when the change was made, you also know who made the change. Maybe it was your angry intern who made the change because you were not paying him, or maybe it was your wife who changed the code because you were not there for lunch or dinner at the same time. Maybe your husband changed it because he wanted to mess around. It also allows us to collaborate on projects. I can send my code base to you, and both of us can share the code base hosted on GitHub or GitLab. Now we are talking about cloud, which is a server where we'll have a Git kind of system hosted, and our code base is managed there. So both of us can collaborate. So you can change the code, I can change the code, you can see the code I changed, and I can see the code you changed, and so on. We can roll back to changes. Maybe we fixed something hoping that it's a new feature, but it actually broke something else. So, and it's midnight, we don't have time. So we can just roll back to the old code base, and in the morning we can think about, okay, how do we make this fix proper? Then it also maintains a full history. And this can be used to promote your employees also, because you know how much everyone worked at, because you can go on the GitHub, for instance, and see how much everyone's coding and how many bugs they're fixing. In short, VCS or version control system help us provide us clarity with when we did it, why we do what we do, what exactly changed, who changed it, and we can roll back to another version. Now imagine we're not talking about code or files or something. We're actually talking about life. Imagine your life, okay? And imagine where you are today. Imagine that there was a system that we know why we're here, and something messed up with you, and that's why you are here. You can actually figure out why they did something to you. You can know exactly what changed, who changed it, and actually do a time travel. Isn't that magical? Would you not like to go back to your school and change something? Or maybe just go back to your school and live that life again. Maybe do the same mistakes, but just relive it. That is exactly what VCS does for our software and files, but unfortunately for the life, we don't have anything. I'm hoping this is clear, and till now, if things are clear, just do a hands up, not the hand up. There's a hands up smiley icon that you can see, and you can share that to make sure that you understand what we have just discussed. This is a hands up. Can you see your icons on the bottom? There's a smiley there. Reactions aren't enabled. Okay, it's not enabled. Okay, then you can just send a text that, yeah, good. Let me check the settings quickly. Yeah, reactions are enabled, but all right, no problem. Cool. So lower your hand, and if you have any question, then now you can raise your hand. No questions? Cool. Okay, good to go. So this is how things are going to be. We have to do this thing called git init. So what is git init? So you have to go in a file folder and open that in a terminal, and then just say git init. Now that might be very complex for someone who is doing it for the really first time, but let's see what exactly we're talking about. So let me open my and we're going to go to 2025, and I made a folder for today called FOSS. Okay, now here I'm going to make a folder which we can make from here, and let's call this today, right? Now I need to open a terminal, so I can do using my command prompt. I need to copy the address I'm at. I go in that folder. Let's believe that's folder I for me. I have a lot of drives, and cd into that. So we are in that folder. Clear? So something similar we'll have to do on your Mac or your Linux as well. The moment we're inside, we need to type git init. And of course, the spelling is wrong. Git init. Okay, so now it's initialized and saying that it's using master as a name. So this is the state where we are in. Are we clear till now? Master is the master. Like there's nothing more truthful than this. There might be other histories, but this is the main one where we are as of now. And it's going to create this invisible folder called git, which is going to manage everything for us. Now, what I'm going to do, I'm going to actually open, why not, let's say, open something that you may not expect to work. Let's say Word. And here's the Word. And let's type something. New line, and let's save it. And it's going to be a nightmare to go there and save. But here we are, and we're going to save this as new doc. All right. Now we are going to close it. Now let's go back to a terminal. By the way, you'll not have to use terminal always. I know it's threatening to look at when you're there for the first time. But then let's type git status. It's telling us that we have this file called new.docx, but it's not committed yet. Everybody here on this call, I think, know about what commitment is. You know what commitment is, right? If you have an affair and you don't commit to it, then you're not committed to it. That's what this is also telling us, that you're having an affair with this guy, but it's not committed yet. Are we clear? Okay. Now, next thing we need to do is to do this thing called git. It's a very dangerous command, by the way, so don't use it regularly. I use it very often, but very dangerous command. Git reset -- hard, and that file is still there. If you open the file, you're going to see the line is also there. Anyone, any ideas? Okay, I don't even know what you're expecting, so let me explain. Let me go back here and let me delete this file. And let's go here again, and let's do something called git add dot, which means everything that's there in the folder, add it to our this thing called staging area, which is the area that we want to commit, right? And we have this command to make sure that maybe we have 10 files, but only 4 files you want to commit, you want to have the history of, but the rest of the 60 are okay, you may want to do that later on. That's why we have this git add, and I can actually add a file name also, but I don't have any file here. So I've added everything that I have in this folder. Then I'm going to say git commit -m. M is for message, and here's the message that we want to add. This is my first commit. All right. So now if I do git status, it's going to tell me that there's nothing to commit here. Everything is properly done. Now let's go back and make our new file here. And let's click, and right, this is our new file, and Save this. New doc and close it. Okay. Now imagine that today is 24th of February and we want to see what all we have done. You can do git status to see what has happened. Oh, there's a new file that's there. It's called knee.doc, not new doc. And we can actually do git diff also. And it works for some files. It doesn't work for all the files. For example, for doc, it didn't work, but I'll show you for Python and JavaScript and other files, it's going to work. Now we have this new doc and we added it. It's not committed yet. So now if I actually go and do git reset / hard, still not going away. There's something wrong. It's going to remove the okay, let me check this. The file is not a part of Bittracker, yes, I believe. Modified, yes, then git diff. It's telling us something has happened, correct. Then new doc added with comment. I'm hoping now this time when I open it, the new line that we added should not be there. And it's not there. Okay, at least this demo worked. I'm hoping you getting an idea of what we actually are trying to do. Then, and you have to do this every time, unfortunately. So now we add, let's say, a table here and add some content. So this is row 1, row 2, row 3, and row 4, and we save it. And this is an important step for us. So all you have to do is to go back and say git add the file that we added, and then git commit why are you committing this particular change. So, and it has to be in quotes, added a new table that explains something. We don't know what it is explaining, but now we are here. Are we clear till here? If you're clear till here, just say yes in the chat. Okay, the next thing that you need to know is basically this thing called git log and / one line. One line because if I don't do one line and see what, this is what I get, I don't want that. So I just want / one line. Now you're going to get things in lines on what all the commits that you've done. So you can see that here right now it says that our head where we are is focusing on the master and we are at the master also. But we have this old commit number also. Now all I have to do is to say git check out this number and I can actually go back to this one. Clear? So if I say git check out and 600915E, then our head is here. And if I now open a file, the table is gone. Are we clear? Head is detached at 00600915. Are we clear? And that's how we see where we are and what are the future branches that we have. Okay, now let's magically go back to a new branch, the master branch, where we actually added that table. So what do I have to do? Can you write that command on the chat? Git checkout what? You're not helping me. Are we good? Yes or no? Perfect. So that's Git for us essentially. Okay. Now I told you that we can do it for a lot of different files. So you can do Blender files, you can do doc files, Excel files, presentations, everything. So in fact, if you know about Git and you don't use it, it's illegal. Okay. It's literally illegal. If you know something like Git exists and you don't use it, then really bad. I've ran EV startups, AI startups, and schooling, of course, then electronics, then design, and I enforce that everybody there, even if they're not engineers, they use Git. It's a very simple system, but if you do Git, then you can actually take a backup of everything you have done, and you can actually sync it to online also for some things which are not really big. Git has a limitation of the file size, and all of that you will get into once you get deeper into. I'll not complicate what you already know today about Git, but that's good enough to get started. So what did we do? We took a working directory and there we did something called git init. So for us to use Git, we have to do two things. First of all, you have to go and download Git and install it. And after install it, it's going to ask you a few questions. It's going to ask you, are you married? It's going to then ask you, what is your age? Then it's going to say, the content you're about to see is 18 years about. Do you want to proceed? You have to say all of that, yes. Then it's going to say, what is your credit card number? Then it's going to ask your PIN. If it's doing all of what I said, then that's a wrong Git you have downloaded. Don't do that. Download the right Git from the Git website. And after you download it, it's going to ask you a couple of things. What is the email ID and what is the organization name, something similar, or maybe your name. And that's all it needs to know, right? So it'll ask you what is the email ID, because now when you're going to commit a file to, let's say, a cloud like GitHub, then on GitHub, it will come as that aditya.sharma@gmail.com committed. So it just need to know the email address. And when you are going to do GitHub integration, you can ask ChatGPT how to do it. You'll have to provide your password for GitHub online also. So, but it's safe. Don't worry. Everyone uses it, including Google. Okay. Then when we say git add either file name or dot means everyone. And instead of that, you can say file name also. If you do that, and then after that, when you say git commit, you're here. You've moved your file to your staging area. Right? So we start with working directory. Whatever changes you are doing, git add is going to add to the staging area. So that now can be committed. And moment you say git commit, it moves to your head. So you're finally committed. Git add tells us what are the files that we need to track. Let us look at an example. Now I'm actually going to do a new file here. And I'm going to call this file passwords. Okay, and moment I make passwords, and I can actually open it and write my password inside it. So I can say Gmail password for me is Tesla @1234 hash, and save it and close it. Okay, and then I can go here and I can say git add git commit -m new file added. Now everybody in the world know about my password. That's one example why you may not want to push everything inside. Second example would be that you've added a 1 gigabyte video file here which you do not want to see. You may have it on your computer, or it may be because the file itself is very big, like training models for LLMs. They are super huge. We may not want to share all of that. Or maybe you've installed some backend Python library that is just there to support your program, but we don't want to push it to front end, or for example, Node, and so on and so on. There's a lot of stuff that we do not want to go forward. So for that, we need to create another file. For what? for making sure that such files are not going to go ahead. So for that, we need to say dot git ignore. So we make a file which is called dot git ignore. Are we clear? All right. Then I'm going to open my Sublime. It's a favorite text editor that I love. And I'm going to do the window here. I'm going to open .git ignore here. And then what I'm going to do, add files that we need to ignore. So how do we do it? So let's say we're going to make a folder, and ideally you should do it before everything starts to make sure that you're not doing the mistake I just did after creating a file. Then I'm trying to do something. So let's not do that. So let's say .json. I don't want any JSON file at all. And let's say passwords. I'm going to make a folder called passwords, and everything inside this folder is not going to be there, and this needs to be at the end. Or and the way we specify file names is not .json. We have to say star.json. Star stands for everything, or everything.json file will never be added. And there's a specific file inside a config folder called secrets, and you will make these files .json, and those files also should never be committed. Are we clear? Right, so we are right now just talking about the files that never should be committed. secrets. Perfect. Now we can close it. Okay, and let me open it also again because I need to remember what all is there. Now I'm going to create a new folder, and I'm going to call this folder password. Is the spelling correct? Spelling is correct. And I'm going to go here and ask git status. And of course, I've done a mistake. I've not pushed the, see, these are the mistakes that you will also do. I should have pushed it before I made the folder passwords, because now it will start tracking it. So before I do anything, let me go back and create this. You have to have some, let's say, what the git status is doing. Git status is doing .git ignore is not added. Perfect. Okay. Wouldn't line 1 take care of line 3? It will take care of line 3. I'm just sharing an example of how you can specifically talk about a particular file in a particular folder. It will take care of line 3, yes. So git add dot, I'm adding everything. Okay. Now my git is also there. Git ignore file is also there. And git commit -m. Do talk about why are you actually doing this addition. So added a, and your comments are going to be read by you in future, and you'll not believe sometimes you're going to add commit, sometimes your commit going to be finally, sometimes your commit going to be thank god it fixed, sometimes you're going to be saying and this you have done on, let's say, 1st of January when you were drunk, and on 24th of February, you're going to look at your code and you're going to see these commits with these messages. You realize what I'm talking about? Do not leave these kind of messages. These are messages to yourself. So added a file called cool. Now let's go and make a new folder called passwords. Okay, so nothing to commit, working free. And we also see a message here, head detached from 97A10. So let's see what is happening. Git status git log -- online / all. If I don't do all, let's see what happens. I will see everything. But if you don't do all and you are at a older commit or you've checked out older branch, then you may not be able to see the future one. That's why it's better that we write dash dash all also. Okay. Now what it means is your master is here, your head is here. Master. Let's talk about why do we have all of these concepts of master and other stuff first. So we discussed that you have a folder, you have done git init inside, init, and after that you're saying git add. When you do add, you're adding those files to a staging area. It's called staging area, that they can be tracked now. Then after that, when you say git commit, you're moving them to here, this particular space. But after that, we have one more step. And this step is going to be common for all the people working in your organization. And this step, like loosely put, is going to be your GitHub. So here you're going to say git push, something like that. So when you say git push, you're pushing it to something which is going to be the central repository of everyone using the same code. Imagine you're working on one feature, I'm going to work on another feature, and all of our features must be inside this main repo. So when you say git push, you're going to be pushing at this particular part. And this guy is called master. Are we clear? Yes, no? Okay. Now, but I'm not doing that right now. So on my own computer, when I'm doing a proper git add, git commit, and so on, the master, the imaginary master, keeps moving with me. And right now here is a master. And if I were to git push, I will probably want to push this. But if I check out an older branch, my head, which was here, my head was pointing here, is going to point here now. Right? So my head is detached from the master. Unless I make this the master is going to be different. I'm hoping you're getting some idea of what I'm talking about. Master is something that you want to actually submit to someone. Head is something where you're making some changes. And the moment I make a change here, unfortunately, it's going to start a new branch. And I can continue on that branch. And I can commit as much as I want. So my head will keep moving with this new branch, but my master is here. I can decide to merge the changes, or I can decide to move my master here itself. Two things are possible. Either we can merge, or we can move the master. If this is not confusing to you, you're lying, because it was confusing to me for the first time. But it will not be confusing to you if you continue to do this on your computer and learn more about it. What is head? Head is where we are pointing to. Again, because it may get confusing from the point of view of a single computer, let me explain this from the point of view of multiple computers. So again, this is the master stored on a special drive, for example. And here you are, you checked the code out, and this code is sitting on your system. Your head is pointing to this. Right now, your head and your master are same. Now, when you make a change to this, it's going to become slightly different from this guy. Let's say this was version 0.1. This is going to become version 0.1.1, right? Now, the moment this is different, your head, which was pointing to your repo and this repo also, is now detached. Detached means it's not focusing on the head. Your head and your master are not same. You can agree right now, right? Unless you submit all the changes to here, and this guy, this master, also becomes v0.2, your head will continue to say that your head is detached from the master. And moment you merge your changes or push your changes, then you're going to be pointing to exactly the same content that your master is. In fact, what we discussed right now, right, just go inside the passwords and discuss that, because we can look also on what is happening. So code online is called master. Code online, download it. This is head. Question to you: head attached to master? Yes or no? Yes, right? because your code and the online code are exactly same. So right now your head is attached to the master. Okay, code online, which is downloaded and changed by you. Your head is here. Now, is the head attached to master now? Definitely no. And you can see why, right? In fact, another scenario, code online changed. Then is your head attached to master? So someone else changed the online code and they made it master. So again, your head is not going to be on the master. So as long as there's a difference between where the head is and where the master is, you will see that your head is not attached. So you have to make sure that you actually attach it back, right? So in my case right now, I can see that my master is here, but my head is here. I like this guy to be my master. So for that, I need to say git branch -m master. Cannot rename the current branch while not anyone. Detach from head. When the password file is never pushed to git, do get ignored? How do we know? When the password file is never pushed to git due to git, how will others know we are setting up the repo? No, it will never be pushed. It will never be pushed because it will never be pushed because it doesn't get ignored. So no one would actually ever know that the password.txt file is ever there. Okay, now let's look at this again carefully. Git log slash line and all. What is happening? Head. This is the head, and oh, sorry. So I was trying to do something else. So I need to make sure that 6E44B8F is the master. So to make the current state the master, all I have to do is write git master. Are we clear? Okay, so there's a lot that you can do with this, and I'll request you to go through. I'll share a PDF version of what we're discussing here. There are a lot of commands that you need to go through. Make sure that, especially if you're working for the first time, copy whatever you have, share with ChatGPT or anything that you're using. Get to learn what exactly you should be doing. Think again and then do it, because if you mess up here, then there's no falling back. It's very difficult to recover a few things from here. And we have a lot of commands that you need to think of. Git init is to initialize a directory to make sure the git is following it. Second is adding something so that file can be tracked. Then committing that file so the current state can be remembered. Then push, which is us pushing it to the master or pushing it to the cloud. Master can be on your own system as well. Then pulling back the code from online. Maybe I've made changes and you're not aware of it. And then git checkout. Checkout is to use to switch between different branches, as we right now saw me using also. Okay, so I've done all of this. We have installed. For Mac, you're going to use brew. For version, you can just check. This is to check whether your Git is installed on your computer or not. And first time you write, everything is going to be in the local repo. You are never going to delete anything. Remember that. If you have done git commit once, that can never be deleted. Just to remind you, let's imagine there's a text file. It's a small mistake that actually we have done at our company. We added this text file to our Git. Okay. And this text file just used to take some logs from online service that we were running and then delete it and then create a new file. And then delete it and then create a new file. So if you go and check the storage, you're going to see that we had around 10 gigabytes. The file size was literally 1 KB. You can understand why, right? Because Git is going to store every single file. So once you have Git, you cannot get rid of the history. It's like the ideal taxation system government of India might want, or ideal tracking system you may want for your enemy or your friend or your, right? So if you commit it once, it's never going to go away. Yeah, so moving to install a Git, then you have to explain what is the name and what is your email ID, and now you're ready. And of course, online you can use GitHub, and locally you just have to install Git and continue with it. This is what we did. Went inside a folder, wrote Git in it. And it said we have initialized the repo there. And after that, we staged it. Git status, there's nothing. We did not add anything to the folder. Then we added a file called file.js, and it said no commits yet. And I have this file, but we are not, it's not committed yet. Then we committed a file, git add file.js. Now you can see that this file, the changes to be committed, file.js is there. I'm tracking it, but you have not committed that file, right? Add is to tell Git track this file. Commit is to actually commit the current state of the file. Then when you make some changes and make good comments as well, and we go on. There's a lot of commands. Don't get threatened by all of this, because whenever you need any command, you're just going to Google it like everyone else does. No shame in that. But after that, you're going to learn a lot of stuff. For example, my favorite command is git diff. Terminal is closed. Git diff, because it tells me the changes I've made to a current file, and I can see step by step. But all of that is also included in this thing called Visual Studio, and we're going to be using it in a moment. Okay, so that's all on the Git. Whatever I told you today, make sure that you practice it out as much as possible. Make file delete, try to make changes, and try to go to a particular stage just to make sure that in future, if you get stuck in a particular problem, then you know how to resolve it. And of course, there's a lot of online resources, especially things like ChatGPT and Claude, that can also help you out. Okay, so now we have this thing called Visual Studio. Now, people who are really new to this, it's little an IDE that you can download from. IDE is something that we use to write code in. So just write Visual Studio Code, and you can download for your Mac or your Windows. It comes in black and white theme. Not black and white theme, black, comma, and white theme. And it does a lot of stuff. It has this thing called Copilot also with it, which is something that you'll actually start falling in love with. So here is our Visual Studio, but I also like to use something called Cursor. Cursor is the state of art right now. Visual Studio is also good, but Cursor gives me everything that Visual Studio has, but it has something more also. My Cursor is paid. You may want to start with a free Cursor, and free Cursor is, I think, available for 15 days, I believe, or some 200 or 500 commits. Let's see. Cursor.com. Now, Cursor.com again gives you a code editor. It's a Visual Studio only, but they've just modified it a bit. And on the pricing side, free, you get 2 weeks and you get 2000 completions and 50 slow premium requests. And here is my cursor. And it's going to show a lot of code that I'm using to teach my other students also, but let me open a new window. Close this at the back. And now I'm going to open a folder. Okay, now same folder, same files that were there are also visible here. Control plus is going to allow me to make it bigger or smaller. And I have something called view terminal here also. And if I do new terminal, it will open in the same file directory, and the same git commands are available here. Right, so we can use it directly from inside also. Now, the reason cursor is different is because everything is fine. I can go here, file, create new files also. And one file that we're going to create is going to be called new text file. Right click, new file, and that's going to be python 101.ipynb. Now, based on the file formats, cursor and any other ID will also understand. Cursor is available for Windows OS only for, no, I have a Mac, I use cursor. It's there for Linux, I don't know. Okay, now based on the file formats here. Here we're using IPYNB, which is IPython notebook, short form for that. The moment I enter, it's going to give me this kind of UI. And it's saying detecting kernel. So there are two ways to deal with Python. I can create a file called main.py or anything called py, anything.py. But we'll not create a file called anything.py because there's some etiquettes in programming also, but this is one way of making it. And I can write, for example, import. It's simple. It's as simple as literally English. Let's say we want to print something, so we can say print, and here we send our message, hello world, and save it. And when we want to run this Python file, the good part is that it's not as complicated as C++. In C++, you have to take a file, you have to compile it, and then it runs. Here, all of that will be done by the Python that is already installed in my system. So all I have to do is to say Python and the name of the file and press. If you understand what just happened on the screen, just give me a smiley. It's good to look at smiles on a chat. I hope so for me, it actually says that the reactions are enabled. These settings will apply when reactions are enabled. I think I'll have to go back to the main. Just give me 1 second. Let me see if I can actually modify the main. Send reactions. Okay, now can you send reaction? Nope. Don't worry, I haven't left. I'm just trying to see if yeah, it says the action is not available, but I just enabled it and no, I don't think not available. No problem. I think I disabled that early on, thinking some of you may send weird thing. Python seems to be working with cursor, but Git giving error. You have to install Git, remember? So you have to go to Git, download Git, and then install it. Okay, so this is one way of running Python. And if you've done it, then just check with. Have done that. That shouldn't happen then. Maybe you've not enabled it for everyone. If you're on Windows, then yeah, you have to go and make some path changes. By the way, not a part of the session, but this thing called edit environment variable, moment you enter programming, this thing is going to be your biggest enemy because you have to go and manually sometimes go inside environment variables, then go here and look at this path guy, then click edit and then add the new things that, if example, I install Olama, I have to go here, not Osama bin Laden, it's Olama, there's something else. You have to add it here, right? So, and a lot of other stuff also. Anyways, so remember that Windows is not as easy as our let's say Mac would be. But this is one way of running Python files, but we're not running it like that. We're going to run it like this. This is an interactive mode. In the interactive mode, still detecting kernels. Use this. In the interactive mode, I can click this thing called code, and I can write the same command here, print hello world, and press enter, and the same thing comes there. Are we clear? So instead of running in a file, and every time, see, if I were to use this, then I have to go here, make some change, and then Python. Make some change here, then again say Python that file. Make some change there in Python that file. So it's cumbersome. That's why we have this thing called interactive notebooks. That's why it's called interactive Python notebook. So everything can happen here, and that makes our life very, very easy compared to anything else. We haven't spoken about cursor yet. So let's do that. So I'm going to press Control I on my system, and I get this thing called this box. This is the interactive mode, and here I can specify some context. I don't want to give this file as context. I'm going to close it. and I can talk to it. It's actually the chat GPT built in. And let's say I want to make a school, and I don't know anything about it. Okay, let's say I want to make a cool uh, Chrome extension that changes the text that I have on any website into, I think we're using sans serif, into a serif font. Okay, that's the feature we want to make. So let's do that actually. Make me a Chrome plugin that, once enabled, changes the font on any website to serif font. Tell me how to install this plugin and share whole code. I'll help you. I'll have you create a simple Chrome extension that changes the font. Oh, it wrote a code. Okay, you can see the speed at which it's writing the code. Okay, and I'll create an SSL files and explain how to use it. First, let's create a new directory called serif font extension, and it was assuming I will create it, but it assumed that the FOSS is that particular folder itself. And then it wrote the manifest file, which is manifest.json, this file, and I can accept or reject these changes. Added some comment there. Then font family serif, and then some icon.js, icon.html file installation. Let's accept all. Okay. Create a new directory called sans serif font extension, and create the files above in that particular directory. Okay, so right click, new folder. Which folder is saying serif font extension? Okay, and I think it made this file, and this file, and asked me to move it here. Either use icon.html or put a icon16.png. Let me see if I have some cool icons. Do I have good images? It needs to be a small image, so not like to make a big one. I can actually make one. So Control-Shift-4 on my screen, and I am going to take this small cross section. I'm going to save as icon.png. I don't know what format it asks. Let's just save it as PNG. Okay. Oh, but it needs 3 files, icon 1648 in. So reveal in File Explorer. I'm going to take that PNG, Control C, V twice. First, it wants a 16. By the way, all of this is not required, but I'm just showing it to you because maybe if you want to spend more time to think about it, but this is how you should follow it. Follow the full instructions properly because it's giving you, you're paying for it if you were to pay for it. Okay, now go to Chrome and extensions. All right, so Chrome extension. Let it go from here. These are the extensions that I have. Okay, what next? Enable developer mode. I have done that already. Okay, before that, Chrome extensions. Enable developer mode. You'll find the small button there. Then load unpacked. Load unpacked. Select that directory. Okay, so go here, go here, go here, go this. Select that directory. Failure extension. Specified an action, but could not load in the manifest. Okay, I've done something. 48. I did not add 48. I'm sorry, my mistake. It's supposed to be called 48. And I'll say retry. There's 128 also. 128 also. I could have said, because now I know, in the next prompt I would have said don't make any actions for me, so I need 128 also. All right, so now can you please retry? It's done. Now what do? Extension will be active immediately after installation. It will automatically convert all the fonts to serif on every website I visit. I didn't want it for every website, but there. So let me reload this. It's saying for every. Do you see that? Let's open Times of India may already be in this. What are the my other website? I like this website and see. I think all the font is going to be this font. That's how fast things can be done. Now I do not want to play around with this extension at all. So I'll go back to my extensions and I will delete it. But I'll show you a few other extensions I have actually. These are extensions that I've made actually. I'm just going to show it to you. So save. Here it is, and I'm going to remove. Okay. Now let me show you other extensions that I've made. And all of the extension I'm going to show you took me maybe a couple of hours. So this is one extension I made for myself. So every time I open, for example, Canvas, which is the program that I use to teach this in LMS. Right now we are in ERA V1 module, and let me open the FOSS module. The session we are looking at is this one, and it comes with this UI, and I don't like this UI. We have a bar here, I have this icon here, and so on. So I made this thing where it says remove divs, and I click remove divs and gone. In fact, I added a camera also, so I can directly add my camera inside because I like to play around with the camera and move it in different spaces, right? Then I made another extension, which is this one, and this extension is controversial if you're a student, but not for me. What it does is something like this. So let me go to ERA V3, which is the current course I'm teaching. Let me go to maybe assignment 12 and click speed grader. Okay, so I need to evaluate this assignment. I can click this guy and I can say scan. What it does basically is it collects all the information that is there, which I need to see, and puts it in this small window, and it allows me to score here directly. So I can actually check this assignment directly from here. In fact, I'll show you one more thing. That's a cool thing that I think there is. I can go to some of the older assignments, because a lot of times students ask me like, hey, can you go to every single assignment and give us the best assignment? Do you know how time consuming that's going to be? I have 369 students in this program. Going there, downloading everything, it's going to be a big nightmare. But then I have a tool. I can click sum up. Now it is going through every single page one by one, downloading all the content, putting it in a .html file, and actually collecting everything for me. And of course, now student scores and their names are something that I can hide if I want in the backend. So you can imagine the speed that you get. Of course, I can click skip and directly show you the result because I did it already. And result is for, I believe, few other quizzes. For check, hold on. Let's go to 4, 5. And this was actually an assignment for my students also. Here's all submissions. Now if I click this, here are all the submissions from all the students. And here are the Canvas links, the scores they got. So now people can think, why did that guy got this much amount of money, not money, score, right? Then I wanted something for myself, for me to be able to draw differently. So I have this another tool called, it was there, believe me. I may have disabled it, so let me just go and manage extensions. Chrome Draw, yeah. So now I can enable it and reload this because extension is going to be requiring me to reload there. Now I have this Chrome Draw and I made this guy. And one of the good things I like is I can draw something like this. And if I click this, you can see I see 1 and 1, but I can make this 7 cross 7. And now if I draw, you're going to see I get this guy. I can't tell you how much it has helped me explain what convolutions are and how do they work. Suddenly I'm drawing the 7 cross 7 and 5 of them or 7 of them and so on. And it collapses also, of course, right? So I can make n number of channels and decide I can make 7 cross 3s, for example. And erase everything, of course. and draw if I want, right? And all of these tools like literally took 1 day for me to make, and these are custom designed for what I really want from what I want to teach. And disable it because I need to fix one bug which refreshes the page faster than I wanted to. Then I think I also have this another tool. I'm not showing off, by the way. If you feel I'm showing off, then yeah, hell, why not? But BetterLang. Okay. So BetterLang is a very interesting tool. I'm not sure it's still working out, but let me refresh this. And I hope it pick something. Do I need to enable it? 1 second. BetterLang. Yeah, it randomly picks a line on a page and converts that into German for me. Let me refresh this again. Oh, that's free, by the way. We are using free services and sending data to some server which allows few requests for tests, and I'm using for my personal use, not commercial. I have a lot of text here, so it may be taking a bit of more time to figure out. But let me open, for example, news.y Combinator. Yeah, and I can select difficulty level also. Difficulty level, I have tuned in such a way that if the sentence is longer, then it will select it. Difficulty level low, in my case, is only few word sentences, so I can actually start learning. All right, so this is to tell you how fast you can actually create things. And now let's get back to Python. Okay, so we can remove this, we can remove not interested, and everything's being tracked by Git, by the way, if you don't remember. Now we're going to talk about Python 101. So first thing we did is to basically make this file called Python 101, and let's hide this. I think the command for hiding this is Control B, yes. And let's hide this guy also. We don't want this, we don't want this. Okay, so Python 101. Today's session is to essentially make sure you understand basic of Python, or what it is and why would you want to use it, and how do we deal with some of the things that are inside. Hello world here, we already know it. Now here is a thing called a list in Python. List is initialized by these square brackets, and list can take numbers, so 1, 2, and 3. Good thing about Python is and you're going to hear this a lot, that everything is an object. What is the meaning of this thing that everything is an object? Now, if you know other programming languages, then actually becomes difficult for anyone to understand what does it mean. But if you're new to Python, then it's actually very easy. There's this concept of, let's understand from human point of view. Okay. What is the meaning of everything is an object? When we say everything is an object, that basically means everyone is same. There is no difference, right? And vegetarians will understand this a lot, that everything has a life, basically. So you can respect a human, you can respect a cow, you can respect a stone, you can talk to a stone, you can name a stone, you can pray a stone. Whatever you can do to something, you can do to everything. There is the meaning of object. I'm trying to explain this in as simple manner as possible. What happens essentially is, to define something, we have to make a class, and that class can have an object, basically a child. So class defines how something is going to work. So this class is basically like your mother and father. So a mix of mother and father is basically a class. So when you make a child of this, they decide what is the child capable of doing. So everything in Python is a child. Meaning of this is, if you can do something with one object, you can do it with some other object also. And the beautiful part about this is everything becomes discoverable, which means that all I have to do to print A is just write it. Which means if I go and look at the print above, and oh, that also prints. So everything will have this feature where you can see what they are made of. Going back to list, A is a list made of 1, 2, 3. And when I write A, I get 1, 2, 3. I can do print of A. also, but in Python it's redundant. Actually, you can just write it down. It's one and the same thing. But lists are very powerful in Python. I don't have to store only numbers inside. That is a restriction of other languages like C or C++. I can add strings also if I add it properly. In fact, I can add another list inside. And this list can have characters also. And maybe, what else? It's a Boolean, right? So it can have a lot of stuff inside. It can, in fact, I can add something called a tuple. We're going to talk about tuple in a moment. So 1, 2, 3 is a tuple. So list is capable of storing a lot of things inside, and they're fast, they're powerful, and you'll see when to use them and when not to use them as well. Okay, now I'm going to take this back and I'm going to paste it here. I don't want the print guy. Python is an indentation specific language, which means the space before what you're writing matters a lot. So I'm going to just put all of them in a new line and run this. No problem at all. I'm going to copy this, paste it here, and go in the front and press tab and run again. No problem at all. You're seeing something called explicit behavior. I'm sorry, I'm dyslexic. I keep using wrong words. We are using something called implicit behavior. So implicit indentation is handled by Python in some cases. It won't be handled in all the cases. I'm going to show you some other example also. But here Python understands that because you're writing this square bracket at the front and square bracket at the back, I will handle all the space for you. So we do not have any trouble there at all. And it doesn't matter how you write it, it's going to always print in the same fashion. No problem there. But let us imagine that we met this gentleman called Shashi Tharoor, and he gave a small speech. And that small speech was something like this. There's a very long string that I'm writing about the cup that I might soon, which might be full of amazing coffee, and it's going to like be spoken a lot. And because it was a lot, I pressed enter there. And now if I try and run this, it's going to say that, hey, there's an end of line. End of line basically is you pressing enter and moving to new line. That line has ended there. There's an end of line, and I don't know what you're doing. It handled it here, by the way, automatically, and had nothing to do with comma. I don't think if I had comma, I could understand. I hope you're getting what I'm discussing right now. All right, and in 5 minutes, I'm going to open up for questions, so don't worry. Okay, so we're going to come back to this. How do we fix this? Remember, Python is an indentation language. The amount of space before everything matters a lot. Now, let's go back to this. In fact, I have something better. Let's write something more. So here, you can see that I have A defined again as a list. I added a space myself, and I've added this and this and this and this and so on. And I wrote this thing which looks like a hash. Hash is used to write comments in Python. And when you write these comments, you can write something which is useful. So here for 1, we are saying this is a serial number. For red, we are saying the color of the shirt of the student wanted. R, the initials of the back of the shirt. 3 plus 4j is a complex number. Scores in maths and science. 3 and 4, the scores last semester. And then N. Right? So hash can be used to essentially write comments. Okay. Now, let's look at these 4 things. These are the 4 main things that we are going to be dealing with. First is called a list. Lists can take numbers. These are integers. Text. Decimals. These are called floats. Complex number. A tuple looks exactly same, but we have a curved bracket here, and we have a square bracket in case of list. Then we have something called a set. Set can also take anything we want to send it. And then we have D called dictionary. Dictionary needs to have a key and a value kind of pair. So this is the key and this is the value. And we're just writing LTST, and I'm expecting the print of all of them. Now, notice a few things here. The output of list looks like a list because it also has this square bracket. Output of T, a tuple, looks like a tuple. It has this curved bracket in front of it. The output of set is interesting. First of all, the order has changed. 4 plus 5j was here. It has changed location. 3.5 is also weird. I have only 1 here. whereas I entered 2 of them. And then finally I have the string. So a set is not allowed to take same things twice. It can only store unique things. So you need to remember this feature, because let's say you have a list and you want to figure out unique items in that inside the list, just convert that into set. Python is going to do it for you. Otherwise, you will end up sitting writing find is, check with all, delete, find, and so on. So Python is very smart from that point of view. And dictionary looks like a dictionary where we have a key and a value pair stored inside. Right. So now let's go back and discuss what is the difference in list and set if they look exactly the same. Now, before we do that, I just want to show you S set again, that we only have 4, 5, 1, 3.4 and Python. It does not promise the same order of things as which you store it with or initialize it with it. Okay, so remember the order is not guaranteed for a set. Now, how do we get access to the list element and the tuple element? They're same. The way we get access, in fact, for a dictionary is also similar. The way we get access is by saying, hey list, can you give me the index number 0? So in Python, we start from index number 0. This is 0, this is 1, this is 2, and this is 3. A set, when we run this, it's going to throw an error, and errors in Python are written in English. Can you read English? Yes, you can. Can you understand English? Yes, you can. That's why you're in this course. So when Python is going to give you error, the 2 magical things are going to happen. First of all, it's going to be in English. And second, you can understand English, which means you can actually just read the Python errors and understand what is it trying to communicate. Don't get threatened by the logs and errors that come in. So the same thing will not work for all 4 of them. It will work for this, not work for this, not work for this. We're going to see what happens. But let's start with our list and tuple. List and tuple. So we are asking list and tuple, hey dude, can you give me your 0th element? And it's going to come back and say 1 and 1. Let's notice 1 and 1. You can actually cross check. I can say, can you give me your first element? And we're going to see 1 and 1 now. This should be cool. Now, in a list, I can say, hey list 0th element, can you now become 10 for me? And I like to print my list again. Not I, but list. And you can see the first element has become 10. Now I'm going to go back to my tuple and I'm going to say, hey list element 0, can you also become 10? I'm going to come back and say, tuple objects does not support item assignment. So the only difference between a tuple and a list, not the only, but apart from many, is that this guy is something called immutable. And this guy is called mutable. Mutable means it can be mutated. Immutable means it cannot be mutated. What is this thing called mutated? Mutated is basically means it can be changed to something else. So anything that you add in a list can be changed to something else. Anything that you add in a tuple cannot be mutated. So list exists because we will like to add something to it later on. Tuple exists because you're working with something that you do not want to modify. But why would we still want to do it? Because I can live with lists also, right? And have the feature of actually modifying that in future. The reason tuple exists is because the way they are stored inside. They are super fast. Every time you see animation, all the polygons that are stored for everything that you see are stored in tuple because they are not changing while animation is running. That's why tuple. So tuple is extremely fast. So when you want to store something and you know that you're not going to be changing it and you want it to behave like a list. I want to look at the entry number 14. I want to calculate the sum. Anything you want to do, tuple. But the moment you know that you want to actually add something to it, list. I'm hoping we are clear till now. The moment I finish dictionary, then I'm going to open up for a question. So a tuple cannot be modified, and look at the English output, English error. First of all, it's a type error. There are different types of errors that are there, so just look at them as well. A tuple that we are accessing does not support item assignment. Here is an item and you're trying to assign something to it. Tuple does not support that. Okay. Now let's look at set. So we could get access to the 0th element by saying, hey tuple, give me the 0th element. List, hey list, give me 0th element. And let's try and go and do the same thing to a string. Not a string, set. Set is now going to come back and say, I'm not subscriptable. You cannot subscribe to me. I'm not like Netflix that you can pay and subscribe to me. And the reason is actually very simple. It can actually do it, but Python, being Python, decided not to do it. See, what is happening here is a set does not guarantee the position of the elements that you put inside. A set is this actually the mathematical set, and the mathematical set cannot have repeating items. So the only job of the set is to make sure that the items inside are unique. So it actually is going to arrange some things, and this is how it actually keeps inside. So it will never be able to guarantee that s of something, let's say a 0, is a specific thing. It's not there. That's why Python has decided not to implement it. Now, Python is actually a very interesting language compared to any other language, and the reason is because of this guy. Actually, let me open this. You're not into programming and all, and probably not in a group which enjoy memes on programmers and other stuff. But this guy is responsible for everything that is done in Python, along with two other guys also. But he decides. So sometimes you'll have question that, hey, why is something like this in Python? The answer is this guy decided it, and he's still alive, by the way. And if you want to feel happy, he failed at an interview for Python at Google. He wrote Python. They didn't know he wrote Python. Otherwise, I don't think they would have interviewed him. But yeah, that's the story. So set is not subscriptable, and list is subscriptable. A tuple cannot be assigned with any item. Let's now go to our dictionary. Dictionary starts with D. So when you now write D, you're going to get key is 1, 2 is Rohan. Now we were accessing our list by saying 0. In case of a dictionary, tuple also writes 0. But in case of a dictionary, I can't write 0. There's no 0 there. There is a key there. So I need to write my key. 1. The name has to be correct. Okay, so now we're going to be taking a 5-minute break. Break is for you. And generally we take breaks to make sure you can go and do important items in your life. But I'm here for questions. If you have any questions, you can just unmute yourself and ask. But this is, otherwise, this is for you. Shirish.
Hey,
Go ahead.
I wanted to know, can we write function calls inside the list? So when you print, the function calls will be executed and a specific function will be called.
No, they will not be executed. To execute something, you have to, I'm actually going to show you functions only next. So
Okay.
let's say my func, and let's just say print, right? And let's say L equals to, let me call L. Just print the name. The way functions are called is by giving it this guy. If I do it, then you're going to see it actually calls it.
So this could be again a combination, right? A function call, then a number, then a string. It will handle in the same way,
It will
right?
handle the same way, yeah.
Okay.
Rajesh? Sorry, Rajesh.
Yeah,
How are you
yeah,
doing?
Robert.
Long time.
Yeah, I'm doing good. Yeah, but last week also we spoke, right,
But
on
it's
EAG.
week ago.
Yeah. Hi, Robert.
Okay, tell me.
But it's been long time. Yeah, I attended MLOps course, but yeah, after that I didn't join anything after that. Rogan, I do have a query on a cursor.
Yeah.
Can I ask?
Yeah.
Yeah, I use VS Code with Copilot. It's really good. It's increasing my productivity a lot. I understood today that it cursor is also very similar to Copilot. I mean VS Code. So in cursor, do we have a choice to choose LLMs, and what are the typical LLMs cursor support?
The reason I'm using cursor is because my students are mostly Indians
Uh-huh.
and they don't like to pay. So
Okay, okay.
go to cursor settings
But
and
but
go to model, hear me out, and then select this Gemini 2.0 Flash EXP and go online. Go to Google AI Studio. Go to
this
API
one I
key.
know.
Yeah.
Yeah.
And then actually just copy paste the key from there. So yes, it allows for different model selections. It has a lot of inbuilt. I'm using a paid one, but there are a lot of models also. So for any course that I recommend, we are going to be using Gemini. Only challenge is the context length is not going to be as big as the other LLMs for the free one.
Okay, Raman. For EAG course, like we can just download the cursor and choose the
Yes.
LLMs, right?
Yes.
And we don't need to pay. Is it same thing doable with VS Code?
Not
I mean, I do
exactly.
have access with LLMs,
No,
so
I have not used VS Code with any Copilot at all. So I do not know that answer.
okay, Rohan, thanks.
Raghu?
Hey, hi Rohan. Good to be back to your sessions. I just have one question on that get ignore. My question was more like, so if I am a committer and I have created 2 or 3 files and we do a get ignore,
Before or
and
after making those files?
so first I create get ignore, then I prepare
Yes.
those files.
Yes.
So that will never be pushed to the
They
repo.
will never be pushed to
And
repo.
and now you are looking to set it up and run in your local,
Yes.
but you wouldn't be aware that 3 such files are required in some specific format to.
I know those files are shared on a pen drive or secretly. Yeah, not kidding. Because these files have the API, the credentials, the passwords, and other stuff. They're not even
Okay.
emailed.
Mhm. Got it. So that needs to be a passive
That needs to be a
handover.
passive. Yes.
Yeah. Thank you so much.
Okay. Rajesh again. All right, let's go back. So now let's move to this thing called a function. A function is something that does something, right? So it can add things, it can subtract things, it can call something else, it can print out something, it can connect to internet, it can do a lot of stuff. But let's start with a very simple function. The way we define a function is by telling Python that I'm about to define a function, and because we don't have a phone connection or Python doesn't have a phone with itself, we have to write this thing called def. Moment we write def, Python knows you're about to write a function. Now I'm going to call my function something. Generally for Python programming languages, we follow something called camel case. So I'm going to write something like my and then func. And then I'm going to write these curve round brackets. Press this colon. And now my function definition starts. Now I can write anything I want, but you can see that automatically, if I press enter, I'm starting here, not here. This is where the indentation comes in. So this modern IDEs understand when you're writing a function, it needs to be indented. So everything has to come here. They're very similar to how we write our stuff in English also, right? You define your point number 1. The moment you say point number 1, you define something, and then when you come down, it becomes point number 2. But then when you press tab here, what happens? It is indented and you start your text here, right? Then you can write A and then B. Exactly same thing Python is also following. So now I can write print, for example, hello world here, and my function is done. Now the way we call a function is by calling the name of the function, but just the name, if you just call, Python is going to go back and come back and tell us that, hey, you're looking at this thing called function. We have not called it, we've just looked at the object. And everything in Python can be looked like this. You can actually do a lot more stuff about it. I think I can do help on this also. See, I've not defined what that help should print out, but it's actually there. Maybe dir is also there, because I remember dir is there for us. Dir basically goes inside that object and finds it directly. My God, do you see the amount of stuff that is already defined by Python for us? Well, let's not get scared. Let's just write my func and those brackets also, then write it. Now you're going to see it actually prints whatever was inside. You saw me using print, so I can do the same with the print also. It's going to say print function, and I can actually now go and say print something, and I can say let's say print 1, 2, 3. It's going to come back and say print 1, 2, 3, right? It's giving me that print of 1, 2, 3. Now, if you define something, we can delete it also. So let's say we go and delete my func. Okay, it's deleted. Now if I try and call my func, it's going to say it's not defined. Understood. Now let's go and delete print, saying print is not defined. What's that? Any idea? If it is not defined, I should not be able to call it. So this behavior has changed actually. Earlier, earlier, when I say earlier, it was like a few months ago, I could delete print, but it won't just get deleted. Now, there are few things that are inside Python. For example, print is inside Python, right? So these are called system functions. They cannot be deleted. They're always there. And then there are things that we define, and they are spaced in something called user space or local space. We're going to discuss about that also. So we have these namespaces where Python goes and finds something. It will find print as a system function. It will find myfunc as a local function. And I can delete local stuff, but never the things that Python depends on. Okay, now let's go back to our function. So let's define we can define functions like this also. And let's say this function is going to take a and b as two input parameters. And I would like to calculate the sum of a and b. So I can say a plus b, all English. There's nothing different here. And then I can say, not even print, return c. See, this is the problem with, that's why I was not using cursor, by the way, for this class. And then I can say my func, and I need to, let me run this now. Okay, let's look at the error. I told you two things will happen when you see the error. Two magical things, right? First is what? It is in English. What is the second magical thing? That you can read it. So if you read the function, it says that my func is missing two. This is the important word. Required. Then this is the second important word called positional arguments. And these are A and B. Okay, let me change this error slightly. I'm going to go up and I'm going to say my B default value is 2. And I'm going to run it. Look at the error, it's going to change slightly. And tell me what is the slight change. See the slight change? And that slight changes. Now A is missing and B, I've already defined a default value. Okay, so the right way of calling this is going to be providing two values. So let's say 1 and 2. Let's say 5. So if I provide a value, it's going to replace it. If I don't provide a value, then it's going to use 2. So that's how the function is going to work. Yeah, Shishir.
Like Java, you can have this overloaded behavior as well.
Yes.
Is it?
Yes.
So in that case, if you write myfunc without any parameters, you define another one my function without any.
Sorry. Java, I am now recollecting. No, it does not provide those features.
Okay, so if I define another my underscore func without any variables in it, and then try to call my func, will it be able to?
Let me just check, because I've never thought of using this in Python. Yes, overloading can be done. Okay, but let's not confuse others. Today's first class, overloading will be overloading for a lot of people. So you can define with different parameters here, but the idea here is that if you have said I need 2 of them, here I'm saying I need 1 of them because I've provided the default value for the second one. I need to provide that before I can call. So right way of calling this is going to be 1 if I don't know the second input, or my func 1 and 5. And we don't need to actually store it internally also. So I do not need this line actually. I can just say a plus b, and that will also work. So exactly the same code. Okay, now sometimes you may, okay, one thing that you need to be very clear about in Python is that I cannot force the user to always give me an integer here. What do you mean? What do I mean by that? I mean that I can actually call this function, my func, with unfortunately a and 5. I can call it. It may not be possible for Python to process it, and it's going to throw it. But look at this function, def mult, and here I'm going to say a comma b. Okay, and I'm going to return a into b. Bin. Okay, now I'm going to call this mult with 1 lesser 45 and 13, and you know it's going to multiply properly. Well, look what happens if I send something else. Some things are multiplicatable in Python. By the way, this we use a lot in logs, and that's why this exists. For example, I may want to write a log, something like super useful, by the way, if you know this inside some function, okay? And you would have seen this other places also. You will not write equal to 50 times because you'll not remember using 50 or 60 or, but point is that some things are possible in Python. So it's not guaranteed, it's not forceable. You cannot force Python to use or force a user to only give integer for A and B. They are free to do anything they want. The function may break, but that's their problem. So now let's move on. Now let's look at a print function slightly in more detail. So print allows us to put a lot of different things together. So here you're seeing in the first one, I wrote, this is a session. Then I wrote A I'm going to take from the user, which is 3. So comma A, and then full stop, and then B, and then some other statement. So print can be structured in different ways to print different things, but you just need to know that it's possible. Okay, there are some rules in which we need to adhere to in Python. The moment you define a default value for a particular variable, every other variable after that must also have a default value. So if I run this, I'm going to get an error. And error, again, as I shared earlier, is going to be doing two magical things. First of all, it's in English, and second, you can read it. So in English, non-default argument, follow the default argument. Default argument, right? So this is a non-default argument, and it is following a default argument. It's not possible. So you have to make sure that you're providing some default value for D also. Control C, and let's go there, and let's write some default value for it. Then now it will work. So this is all we need to know in the functions as the basic. So you know that what all you can do inside and a lot of stuff that you can creatively do. Now let's talk about the conditionals that we have. So conditionals are super important for us. Let's say A is equals to 10, B equals to -2, and C is equals to 30. Now we want to write if A is greater than 5, print yes. It prints yes. Now there are other ways of printing also, and print you need to be really comfortable with. I can write F, these are called F strings, and I can write yes inside. No difference at all. But magically, I can go inside and write this curly brackets, and I can say call something, for example, C, which is defined above, and it'll actually pick that value also. In fact, I can do some computation inside also. I can say C plus A. And what else? You can call functions also. Don't misuse it like this. It's not for that. It's just to capture different parameter names for different locations and print them properly. So yes, A, for example, A equals this value. Okay, but let's make it complex. So we had this, and we like to say that B is less than 0. All you have to do is write and B is less than 0. So it follows English. Then you can also say or C is greater than 100. I'm hoping this is clear. You have to go through step by step. You can write and, which makes two conditions together, and then give or, and then that takes another condition also into picture. What comes first, second, don't worry, we'll discuss that. But you can write something like this. Now let's take this back, but I like to change this a bit. Yes, I'm going to say A, and then I'm also going to say C plus B. Okay, now I'm going to take this and I'm going to paste it here, and I'm going to go here and press enter, and I'm going to go here and press enter, and I'm going to run this. You're going to see it says syntax error, and where the syntax error? Here. Remember we discussed about implicit indentation, implicit and explicit. implicit means it understands internally. Explicit means I have to tell Python. Here I've not told Python. So for some things, it doesn't know what has to happen. And in fact, I can't even go there and add that indentation or tab manually and run it. It won't run. It doesn't know. So the only way we can actually overrule something like this. Let's say I do want to write like that. I have to use this backspace. Now we are telling Python, hey Python, that all these things are actually together. And we also discussed that a is equals to, let's say if I write this is a long enter line, it's going to throw an error. But sometimes we do want to write a lot, and I can't be writing this backslash every time. For that, Python has given us a tool, and it's that 3 quotes. So if I go and write 3 quotes, then it's fine. Just to check, yeah, it added that backslash automatically. So some things are automatic, some things are not, and you will learn this without any trouble as you spend more time. But going back to conditionals, in conditionals we have 4 things. We have if, we have else, we have elif, and we have ternary. So in case of this equation that you see here, let's say a is equals to 4, and if a is less than 3, print a is less than 3, else print a is greater than 3. So when we run it, we're going to get a is greater than 3. But then we can have a condition like this also, where we are checking conditions of a. If that is not true, then we are checking another condition for a, and then we have else. So we are saying if this, if that's not true, then do this. And inside that also we have this condition and that condition. There are many conditions that we can actually build through this. But we can also do, or maybe simplify this by something called elif. So elif is a combination of else and if. And this looks easier to read actually. And Python is all about making the code look easier and actually easier to read. Here we're saying if a is less than 15, or else if a is less than 10. So we already covered this, then finally do something like this. Right, so elif is sort of a mixture of else and if, and we can use it without the last else also. It's not a requirement for us to use it, and both of them are not true. So let me write 9. Now you can see that we get this one. I'm hoping you're following. Okay, now Python sometimes, programmers sometimes use Python in a very extreme manner, and that's where ternary comes in. And I hope you do not have to use ternary, because it's actually very confusing for people who do not know what these ternary things are. Let's say our a is equals to 5. Because it's like natural English to look at, people actually write this kind of line which is valid. I'm going to say result. I'm going to print it also, so I'm just going to write it on the bottom as well. RESULT. Result is equals to a is less than 5. Okay, so a is less than 5 if a is less than 5, a is less than, I wrote 5, else a is not less than 5, and let me make it 4. These are called ternary operators. So in a single line you can write something like this. And the way you have to read it is, do this if this is true, else do this. But maybe very confusing for people who may be looking at it for the first time. So keep that in mind. Okay, so these are the conditionals. So what all we have covered that. I'm not covering that we have integers and then we have strings and all of that. I'm hoping that you can guess by the time we are here. I have an integer like 1, 2, 3, 4. I have a decimal like 4.5. These are called floats. Then we have strings which need to be in the quotes. Then we have characters that also need to be in quotes. Then we can have true and false, which these are Boolean. Then we have lists. Before we go there, then we have 4 plus 3j. These are complex numbers. And then we have a lot of other stuff also. But then we have dictionaries also. But here I'm showing you a list. Then we have tuples also, but I'm showing you a set. Then we have list also, but I'm showing you a tuple. And tuple can also store other things that are interesting that we have. And then we have set also, even though I'm showing you a dictionary. And dictionary keys can be integers as well, not recommended. So these are the defaults. So what all have we covered? We have covered the kind of things that we have, like integers and floats and strings. Then we have covered list and tuple and dictionaries and set, the most important stuff that we need. Then we covered some definitions of our functions, how to run. And then we have covered our conditionals. In case of conditionals, we have if, we have else, we have alif lela, and then we have ternary operator, which I do not recommend for use. Do we have long? Do we have int? We have all of them, but the point in the basic session to cover it. Now, the next thing that we need to understand is this thing called module. So I'm going to write import math. Okay, and these imports are very dangerous, and you should, when you look at it, you should get extremely concerned and get worried, and your palms should be sweating, and so nothing like that. I can actually import anything also. We wrote it on top. Here it is. So a module is nothing but a file, just a file that is stored somewhere in Python memory, if it is already there, right? And in the Python, we were just printing something. I can actually write def. Let's call this mult, and I can take A, B, and C, and we just return A into B into C. Save it. And now if I go back, I'm saying import anything, then I can say import, not import, sorry, anything dot, what was the name again? Mult, okay. Mult, and it needed 3 numbers, 1, 2, and 3. I can call it. It has nothing. I think I need to import it again. Yes. Finally. Okay, sometimes the kernel need to restart to make sure that the imports are there. And you are going to fall in this problem later on also, but yeah, not all the time, sometimes. And that happens with IPython, by the way. If I were using it outside, that won't be a problem. So the way we export anything is just by defining it. And I can go and use that file name, anything dot whatever is inside. Again, I can get access to anything that I write here. But because we have not done a lot of anything, let me go back to import math. Now, math is an inbuilt module. What is a module? Module is literally a file that has a lot of classes or functions and other things that is made available for us. Now, by the way, when I say import anything, it has imported everything that was inside. And you can see that the moment I run it, it says hello world also, right? Maybe I just don't want that. So I can actually say, and there's another way of doing it, but I have to again restart it because everything is in the memory. And I can say anything import mult. Okay, now it didn't show anything, and now I do not have to write anything dot mult. Now mult is in my namespace, right? Now if I say import math, I've imported every damn thing in math. I've imported sine, cosine, tangential, whatever function is there, square root, cube root is not there, square root, everything is there. But let's say we do that. Now I can say math dot exponential function of, let's say, 45. Now it's going to go back and give me the exp value of 45, and you can see that there's E19 also, so it's a very big value. And now if I go and say dir, so we have out in something, built in, other stuff, and then you have open, then you have mult, then you have Python. You can see this is the namespace. In fact, it's not big shown here, but these are all the things that are currently in our namespace, right? I restarted it, so the initial few things are not there. So dir basically tells you what all is there that you can use. Now let's call math.sine of 45. It's going to give us some value. Right? So that's how we basically call these things. Okay. Now let's write a function again. So let's say def func underscore 3 a int, because you are going to see something like this, b int return a into b, and I'm just going to run it, and I'm going to say func underscore 3 and a, I said int, but let me write Rohan or red and 5. So there are two things that are happening here. I want to focus on both the things. First of all, we wrote something extra here, colon int, but I could still give red. As I shared earlier, you cannot force Python to make sure that a particular input has to be integer. It can be anything that people want. So why does this exist? This exists to help people know that something like an integer should be sent. And in fact, I'm not writing it here, but if you were doing in a proper API program and I hover my mouse on top of something like this, then I'm actually going to tell me in the help or the space that, hey, can you please use integer? So if I use help, for example, for func underscore 3, now I can see that, because possible that my function is embedded in some file, which I don't know. Here you can see in the function definition is telling us that A is input and int and B is int. So just a hint. Python is just going to tell you a hint. You cannot force it. Okay, now let's move to another very interesting concept. And here, first of all, I wanted to notice this thing called Rohan, and I'm going to assign it to B, and I'm going to print out B. Okay, and this is a very important concept, so stay with me. Now I'm going to write ID, which is like an address of D. In fact, everything has an address. In fact, if I say ID of int, I'm hoping that will also give me an address. You can see that. So D stores Rohan, and when I ask for the address of D, you see that I get this number. Similarly, print gives me this number. Okay, now I'm going to do something very interesting. I'm going to say E is also equal to Rohan. And I'm going to say ID of. Look, magically, the addresses are same. This is a very, very important concept, especially if you're coming from some other programming languages. When you say D equals to something, whatever this thing can be, the way Python works is, Python is going to take this thing, is going to go inside the RAM, and it's going to store that thing there. Then it's going to take the address of this guy, and this address is what is going to be given to D. So when you say D equal to 45, D is not equal to 45. D is pointing to a memory address where 45 is stored. Then when you say D is equal to 11, you're not going to memory address and converting this into 11. No, this is not what is happening. This is still 45. 11 will be stored somewhere, and now D is pointing to that memory address. What this means is, if let's say A is equals to 6 and B equals to 9, and then you call a function, let's say my func, and then here you say A and B, and this is what you're sending. What are you sending? You're not sending 6 and 9. Please keep in mind, what are you sending? You're sending whatever A is pointing to the memory address, whatever B is pointing to the memory address. Before calling this function, there are two things that can happen. Either A can point to something else, or in that memory address something can change. So both of them are something that you need to be aware of. But we never, and if you've heard this term, this thing pass by value or pass by reference, we are always referencing variables. Very, very important to understand. In Python, we never can say my A is equal to 6. It looks like that, but it's not. A is pointing to a memory address that happens to be 6. When you say print, what is print? Print is not a function. Print is something that is pointing to a memory address that has that object that works like a print function. When you say def my func, you're not saying my function is this function. No, this function is stored in the memory, And my func just point to memory address, which when called with few parameters execute something. It's very, very important. So everything that we ever see in Python is not like this. E is not Rohan. This E is pointing to some memory address where Rohan is stored. Okay, but how does the address become same? Now, this is exactly where everything boils down to. Now, Python is a programming language that tries to optimize things. It sees that if you're making something like this, it probably might be a name of a variable or a function. And it does a process called interning. Interning is a process where it sees whether something should be stored forever. When I say forever, as long as my function is running. And it interns that. So it has intern short thing, which is like Rohan, in a memory address somewhere. Now, when I again say equal to Rohan, it's not going to make a new Rohan there. It's just going to make my E point there. In fact, if I say F equal to Rohan also, I'm going to get exactly the same memory address, F equal to Rohan. And if I write F, again the same memory address. 456, 456. Moment I do a mistake, for example, if I say G is equals to Roshan, and now if I say G and ID of G, of course, now it's going to be different. This is 5, 6, 8. I hope you get this. Is very, very, very important to understand that we do not have variables becoming something. When I say A equals to 1, or if I say B equals to 1, or if I say C equals to 1, I'm not making these new memory addresses. A is already interned because all the numbers from -5 to 255 are already interned, and they will have exactly the same memory addresses. So if I say ID of A, ID of B, and ID of C, all of them are going to be exactly the same. Are we clear? I'm taking a break here because it's an important concept. If you have any questions, then just raise your hand. Okay, good. If you've understood, then understand the consequence of what we've discussed and why this makes Python a very, very different language. Now, in case of C, I have to define a variable as probably int a is equals to 45, right? Now, what C++ is going to do, it's going to define a pointer a, again, that is also memory pointing to, but it's going to point to a memory address that can only store integers. This is a difference in Python and C. Right now we're talking about C or C++ or other programming languages. There you have to say int a is equal to 45. So it's going to go inside a memory and create a space exactly that is required to store this number 45. It's going to be stored as some Boolean number there. Now you can say a is equal to 69. Perfect. It's going to go inside and change that memory address. So the old one is overwritten. Then you can say a is equals to 49. It can go back, change again. Then you can say a is equals to red. And it's going to go there and say, oh, oops, cannot be done. It's going to throw an error. A was supposed to be an integer, but you're trying to write a string there. Whereas in case of Python, a is equals to 45 means 45 number if was there, a is pointing to that. Then you say a is equals to, let's say, Sham. I've never written that number today. It's going to check, do I find Sham? No, I don't find Sham. So let me write Sham here and let me point a to Sham. Now, if 45 was being pointed out by somebody else, then 45 is going to be in the memory. Otherwise, it's going to be removed. Let me try and recreate that. Sometimes I fail at doing it, but let's see. Let's say we say B equals to, Rohit, I've not used today. Then I'm going to say B, ID of B. And I'm going to say then delete B. And I'm going to run the whole thing again. And I'm hoping the address will be different this time. It's same, so it's rotated. So this is something that I can improve on the Python file, but not in Jupyter Notebook, because they tend to store all the variables forever and it's not replicatable. But if there is a text that you wrote and actually I can show you something else, not relevant, but I don't know how many times I have to do this, by the way, to show you what I want to show you. Yes, here I can show it to you because these are not interned. this is a very long sentence, and Python thinks like it's a long sentence. What's the point of me actually storing this permanently in a memory? So it's not going to do that. It stores it at some memory location 986. Then I delete B. Moment I delete B, it goes to the memory and looks at, and this is called garbage collection, by the way, in Python. It's going to see, hey, I have this thing stored, but nobody's pointing at it because we deleted it. Then let me just delete it. So deleted that. Then I made B again, exactly the same thing. Then Python has to go and look at the nearest memory location or whichever is available at that moment and assign there. And that's why the address is different here. But for the short strings, it's going to just store it at a particular location, and you will always have access at the same memory address. So very, very important to understand. The two concepts that everything else I've told you, you can learn again. But these two concepts are very important to understand. First thing is everything is an object. You need to feel about it. It's just not some random line that you're hearing. It has a meaning, and that meaning defines how you're going to be becoming a programming expert or a programming novice in Python. And second thing is that we do not store values in a particular variable name. All variable names are referencing to a memory address. Imagine that when I call you and I can see Abhishek, Ajay, Alandra, Aman, Amit, Anand, Anurag, all of you, when I'm actually calling your name, I'm not calling your name, I'm calling your house numbers. That's what is happening in Python. It's very important to understand because it's going to make your life easier when you move on in the future for a deeper Python. And second thing is everything is an object. Because everything is pointing to a particular memory address, everything that is stored inside memory of Python is a much deeper address. It's a much deeper object. You might think that 1 is just an integer, it's just a number. It's not. It has a lot of stuff inside it. It's difficult for me to explain what I mean, but that's not a simple thing. That 1 has a lot of functions and other things also attached with it. I don't know what else I can do. Can I write even dir of 1? I don't think so. Yes, do you see that? That 1 has so many details about it. That's why sometimes people say Python is slow, because of the fact that everything is an object. We have so many functions just for Python, just for 1, right? And C++, in C++, 1 would be some small 8-bit byte, some stored somewhere. But in Python, everything is an object, which means that it has a lot more to it. All right, next. Okay. So next we are going to talk about this thing called loops. Now, loops are also very different in Python. And why are the loops very different in Python? Because of this guy. Can you see the glare in his eyes? The green eyes looking at the blue ocean, telling everyone that I'm going to write a programming language that is very different. He did that. Python is very different. And loops are also very different. Very, very different compared to any other programming language that you have ever seen. And if you don't know about what I'm talking about and you know Python, you might be actually surprised how actually loops work. Now, before we talk about loops, you need to know something that is something called iterable. Iterable are things that can be iterated over, right? English. Something that we can iterate over, something I can go through. 1, can you go through 1? Can't, you just see it and it's done. But let's say I have 1 and I have 3 in a list. Can I go through this list? Yes, I have 2 elements inside. I have 1 and I have 3. So a list is an iterable, but number 23 is not. Similarly, a tuple is also iterable. I can go through that thing one by one. So does a dictionary, right? So first we need to have an iterable for a loop to work. Now let's make something called list again, and we have 1, then we have red, and then we know we can add a tuple inside this also. So I can say this is 3, 4. Then I know we can add a dictionary also, but let's add a set. I know I'm writing 1 multiple times, even though set is going to remove all of them and just make it 1. Then I can add red, just write key and value, so you remember what are these positions for. And the way the loops work in Python is we have to write in English for something. So let's say list for I. Let's keep it simple. For I, for item in L. And and let me just print that. What are we saying here? We're saying for I item in L, L is something that is iterable. I can iterate inside it. For I in L, so for I is this, if then it will become this, then it will become this, then it will become this, then it will become this. Print that thing. So now if I run this, you're going to see we go through each item one by one. That's how loops work in Python. In Python, every loop that we're going to work with using for needs something that is iterable. If something is iterable, we just go through it. In fact, let me try something weird. For character in Rohan, print C. See that? That is also iterable. For I in 1, 2, 3, 4, I'm not even storing it. Print I. That is also iterable. So anything that is iterable, Python can run a loop on it, element by element. Okay, now while we are at list, I just want to explain one more thing because sometimes it's confusing. 1, 2, 3, 4, 5, 6, 7, and then 8, and then 9 will stop at 9. I wanted to understand what is the meaning of this. What's the meaning of this? This is the index number, this one, right? Because we start from 0, 1, 2, 3, 4, 5, 6, 7, 8. Right? I hope this is clear. If this is clear, just write yes. All right. Now, I want you to think about what can be this guy. What is this -1? You're going to see this a lot. That's why I'm actually touching upon it. What is -1? So if our list starts from 0, 1, 2, 3, 4, 5, 6, 7, 8 in this direction, it starts from -1, -2, -3, 4, 5, 6, 7, 8, 9, -9 in this direction. So if I write -1, I'm expecting 9. Let's do some exercise. Okay, so L of -5, what is it going to be? Tell me. Maybe not 5, maybe 8. What is 8? I'm sorry. -8. Good. Okay. Now let's take L and let's say I want to talk about few of the things. I want to only take 2 to 6. So the way we are going to do that is we're going to say 1 is at 0th location, 2 is at second location. So I have to say 1 because we're going to start from 1. And what did we say? We want to take from 2 to 6. What are the locations? 0, 1, 2, 3, 4, 5, 6, 7, and 8. So I have to say start at 1 here and end at 6 because 6 will not be included. So 6. And now you can see 2, 3, 4, 5, 6 are there. Right? So here we can say start from something and end from something. So whatever you write, 6 for example here is not taken in. Again, if you're forgetting, this is 0, 1, 2, 3, 4, 5, 6, 7 will not be taken. Okay. Then sometimes we'll see this column also. This column, if we add, we can ask Python to do a jump of 2. So again, let's look at it. 0, 1, 2, 3, 4, 5, 6, 7, 8. So first of all, we are saying go from 1 to 6. So 1 to 6. 6 is this, so it's not included. So here. So these are numbers we're talking about. So we're talking about 2, we're talking about 3, we're talking about 4, 5, and 6. And then we are saying do a jump of 2, not 1. So I'll take this, jump of 2, this, and jump of 2, this. So I'll get 2, 4, and 6. So Python is very, very interesting language from that point of view. And if you just want to do this in C++, unless it supports now, you'll have to write weird functions, other stuff to just get this done. That's why a lot of programmers, scientists love this because Python is so easy to manipulate data. I can do whatever I want. In fact, L How do we reverse? I forgot. Yeah. Now, what did I say here? Empty basically start from the start. Empty basically end at the end. But don't do a jump of 1, do a jump of -1. It will automatically understand you're saying to actually do a reverse of this. Very difficult in other programming languages. So that's for loop for us, and for loop can go through anything that is subscribable, that is iterable. Then we have this thing called while loop. Now while runs for whatever is in front of it is true. So let me say we have I is equals to 10. So while I is greater than 5, it's going to print hello. Now if I run this, I'm going to enter into a infinite loop. I should not have done that. So I'm going to do a restart. So there needs to be a condition internally which makes sure that I eventually becomes less than, it's always going to be, eventually becomes less than 5. So for that I can say I is equals to I minus 1. Now it's going to run only for a few steps and then stop. Shishir?
Yeah, quick question. So you printed the list in reverse order, right? If you equate it to a variable and then try to print it, will it be a lazy execution every time, or it will store another memory location and store the reverse list?
Okay, good question. In Python, remember, whenever we say left-hand side is equals to right-hand side operation happens in the memory. And then left-hand side points to it. So if I do a reverse of the list, that list will be stored again in the memory and then we'll be pointing to it. This cannot store anything apart from a memory address. So left-hand side always store a memory address.
Yeah, so in memory, I will have ascending
reversed.
and descending order list,
Yeah.
both.
Yeah.
Okay.
Okay, going to while, something has to change the condition for it to actually come out of it. Okay, now let's see one more interesting thing. So let's say A equals to 10, B equals to 20, C equals to 0. Now, if I say A divided by C, what will happen? It's going to give me an English error, which is division by 0. I'm not allowed to do it. But if I say or A divided by 20, it's again giving me the same error. Now, if I do this, no, it does not give me that error. What you need to remember is, in Python, the operations are executed in this fashion. What is the meaning of this? Or basically check, is this true or this true? That's all it is doing. That's the purpose of or. So if this is true, it just returns this. If this is false, then and only then it's going to check this, and then it's going to return this. I've written a condition here which is not valid. I can't divide anything by 0. But because this condition was true, anything that is not 0 is true, that came out and this was never executed. In fact, I can call a function here. Let me call my second function that I never made, and let me send R and T and K inside. Call it. It will still work. So Python is dangerous from that point of view also. So remember, OR is slightly dangerous because you can go ahead with things that are not done. But if you want to show your boss that you've written a very big ass function and very complicated, you can do something like this and tell your boss, hey boss, see, it's working. It's not throwing an error. But internally, you will know with your soul that it's not there. Okay, now the last thing I want to show you is something called finally. Now, if I'm at it, you'll understand finally very, very easily. If you're not, then I'll have to explain a lot. A equals 10, B equals to 10, then I'm going to say try. Now, we put things in try where we're not sure of whether the things are going to break or not. So let me write B equal to 0 actually. So I want to try to do A divided by B. Now, if this happens, perfect. If it doesn't happen, then I'm going to get an exception, and you can see that exception already. What is the name of the exception? A divided by B division by 0 error, right? So you can actually do something about it. So I can say try divide A by B. If that happens, perfect. If that doesn't happen, then except, I need to say except what? 0 division error, and print B was 0. And now if I run it, you're going to see B was 0 is coming out. It's not going to break my program. So the way errors work in Python is actually very different from other programming languages. In Python, sometimes when the error comes, you can catch the error and continue execution, assuming that they are just your console outputs. But that's not what I was talking about. Exception is there, and try and accept are really beautiful things to capture these kind of problems. What I was talking about is this thing called finally. Now finally is going to print doesn't matter what. So finally, you have to listen to me. So we entered 0 division error, but we still have to listen to this guy, and 10 came. This was not a problem, but we still have to listen. So finally is something that you have to listen to always, doesn't matter what. Now if you're married, you have understood finally who has the final say in your home. If you're not married, then this will be a difficult thing to understand. Finally will work, doesn't matter what. You have to get finally as the last statement. It will always work, doesn't matter what. All right, now the last thing we're going to touch upon is a class. Okay, class. The way we define functions is we write def. For a class, we write class. And here we can say, let's say a simple class called rectangle. Now, the first function you're going to see always is this thing called init. And in init, we write this thing called self for some reason. Okay, and then we can write A and B. And then inside, we have to go and say self dot A equals to A. Then we have to say self dot B equals to B. What is happening here? Why do I have to do all of that? Then I can say R equals to rectangle, and I have to provide 1 and 2, and then I can access my A and B's like R dot A and R dot B. Okay, so this is a normal format in which you're going to see your classes written, but that self can be anything. I can actually say Rohan also. It will work. So I want to focus on what is this self thing, and it's called self because he decided it should be called self. And what is this self? Let's talk about that. So we wrote this class. This class has variables like A and B, and later on we're going to say R is equals to this class. Let's call this rectangle, and we're going to say A and B. But we just discussed that whenever we have anything on the left hand side, it's going to be just a memory address. Yes? Yes or no? Type in the chat. All left hand can do is to point to memory address. That means Python has to take this, put in a memory address, and then there define A equals to, here let's say we're saying 9, and then we have to say B is equals to 6. Correct? We have to do this. Python has to do this. And then R has to point here. So self is the first memory address that Python creates for this guy. Self is the term used inside Python to talk about this memory address. So self.a is already this address. Self.b is already this address. So now when we go inside and say self, right? Inside it knows, oh, self.a, this one. Oh, self.b, this one. So whatever R is pointing to gets replaced by self word internally. You can actually, if it's confusing, you can actually just say address here. Then it should be clear. But then it's add, it can be anything. So you have to use some term here. So that's why we just call it self. Self is nothing but the memory address. And for that, let's actually print self also. And you can see that it's actually saying what? It's saying I am main rectangle object stored at memory address. In fact, I can go and print out ID of self also. And now you can see that this is the memory address where it is actually pointing. So self is the object itself in the memory address. It's an object, basically child of rectangle, which gives me the memory address. And this is the memory address it's stored at. So whatever self is pointing to, in fact, let's see another magic. What do you see? Do you see the magic? Are you happy to see this? Okay, if you're not happy, then say yes. If you're happy, then say yes. So that is what that guy's self is doing. You can call it anything. You can actually call it Modi also. You can't call it Ajit Doval, by the way. If you call it Doval, then he will know. In fact, let's do one more print. Print self ID of self.a and ID of self.b. Here ID of a dot r dot a and ID of a r dot b. And you will again see that the use of self is to basically point to memory addresses, right? So now the address where this A and this B is saved is exactly same as this A and B outside. So self is like the communication between the R and the memory addresses inside. So self is the memory address, basically. That's what self is doing. Okay, moving on. But classes are not just for that. Classes allow us to extend things also. So here, for example, I've added two functions inside. And again, you're going to see that we have to say self. Which function are we talking about? Because that function needs to access some variable. If we pass on self, then it knows the self, which is the address, and self.width, that in that house, in that room, it can go and find width. In that house and in that width it can find. So self is like our house address. And everything house dot kitchen, house dot room, house dot washroom, house dot water, everything now can be internally communicated using this just self here. Right now, when you write your own classes and you think about should I have self here or not, just think about yourself, just not yourself, the class. Think about the class that, okay, I'm talking about something that the class knows. How do I know where it is? So that's where you have to use self and become very easy for you to take it forward. So that's how we define a class, and that's how we can actually call a function also. Now this function area is calling self.width. Self.width is going to be what? 10 and 20, right? Width and height. So now it can calculate that and give us that output. Karthik?
Yeah, Rohan, one quick question. In the example before this, when you printed self.a within the class, the only reason we got the ID of it was because we had already run a as like we had run the r is equal to rectangle 1 comma 2, right? Otherwise, it would have
Yes.
given an error.
Otherwise, there's no other way to call it. Init gets called immediately when this is made. So if I don't write this line, this is just a code sitting somewhere. This is not converted into a memory.
Got it. Clear.
Okay.
Makes sense.
Madhuri?
I think I had the same question is that what if I like R is one instance of it, but what if I were to write another instance? Would it give
Yes.
me same ID? But I think as you mentioned that it like once the running an instance
Exactly.
runs the
Good fine.
initiator function and A and B whatever they would be, they would like the structure is same, so they would refer to the same memory like ID in the memory. Is that correct?
If I were to do R1 equal to rectangle and R2 equal to rectangle, first Python is going to find a new memory address for R1 and assign everything there. Then it's going to find new memory address for R2 and then assign it there. Self in that case is talking about house number 104. Self in the second case is talking about house number 109. I hope you get what I mean.
Okay, so I mean, what I took from that is that like it's defining the blueprint of how to
Yes.
fetch the IDs of a instance, but the IDs for different instance would be different
Yes.
because they are taking different memory spaces.
Correct.
Okay, yeah, thank you.
self is mandatory, yes. Okay, now here we wrote just area and perimeter, but now let's call a dir on R1 and see what all function. Oh my god, so many functions. There's so many functions inside. Area, height, perimeter, and width is something that we added, but then Python has all of these functions. This is greater than equal to, the greater than hash in it. We wrote about it. Then less than, equal to, less than, new, reduce. There are a lot of functions that actually Python writes for us, and these are all empty functions as of now, but we can extend them. We can override them and write more detail. For example, let's talk about this str function. Now, when I say r, for example, just r, I get this thing. But if I go to my class, and if I enter the class here again, and then define def here, these are called dunder function because we have double underscores. We just call them dunder functions. Shirish?
Yeah, why are these functions empty? If there's nothing inside it, why would Python provide an empty function?
So we can override them and okay, so we have a base class. Because you've asked me, you have to now understand this. The first class in Python is called type. See, when we say everything is an object, that means everything is a child? Yes or no?
Yeah.
And a child can also have a child. But there has to be a parent somewhere. So when we say everything is an object in Python, we are 99.99999% correct. Because there's only one thing that is not an object. It is a parent and object at the same time, and that thing is called type. So everything is a child of type. And the type, because everything is a parent or child of type, the type has all of these empty functions, the function that it uses. So you get all of these DNA free.
So Python never provides a default implementation of it.
No. Because we're subclassing type and type has all of this empty, and it uses this for something, some other things also. So some other stuff it uses for its own objects like integer and others, and where these things get used. So there it has to provide for.
Okay.
Repr. That's what I was thinking. What is it? So they have this repr function. So if you override repr function, then if you just write the name of the variable, then it's just going to write this. So it provides all this. For example, okay, it's not crashing, right? It's telling me false, but it's not crashing. The reason it's not crashing is because the computation is already written in a Python function, but that function is empty. I have to write that function myself to make sure that I check something like this. So if Python doesn't provide an empty function, then we are troubled. And the way we can do that, override it on empty functions by writing this EQ. So if I now override this EQ function, which was free for me, and if I do 10 and 20, if I check, let me just delete this. I'm going to see yes. Okay. Now, okay, very, very important thing to understand. So let's say A is equals to 1 and B equals to 1. There are two ways in which we compare things in Python. First, we can say A equals to B, and we can say A is B. Both of them are different things. meaning of this is we check what is A pointing to, and we look at the value of that. A is pointing to a value 1. Then we look at B. We go to where B is pointing, and B is pointing to value 1. And the meaning of A equal to B is that these two are equal. Got it? Yes or no in chat? Okay. When we say A is B, we check what is A pointing to, and we check whether B is pointing to the same thing or not. So A is B is a check of the same address, whereas A equal to B is a check of the value that is there. Let me quickly show it to you. So my func def, I'm just going to write a very simple function. Turn 45. Def B turn 45. Then A equals to B, and A is okay. Got it? Sapna?
Yeah. When you wrote R1 is equal to rectangle of, earlier it was some other 35, 42 something. And since we are not calling any functions here, is it not like init serves as a default function and we are supposed to write what is in there instead of I am an amazing function? So why did I am an amazing function print there?
It didn't print here. It printed.
No, over here, when you just gave, before RT, you just
got
gave
it. One
R
second. Got it. One second.
something to print that.
One second. So R1 equals to R2 is actually equal to R1 dot underscore EQ underscore R2. So when you one second, when you write expressions like these, Python automatically converts it into expressions like this for us. So it understands what are you asking, and the conversion happens automatically. That's why R1 and R2 never printed, because this becomes one expression.
Okay, so
when you say A equals to B, Python understands this as an expression where you're talking about A and B.
yes, yeah, I got this. Before this, when you just before writing EQ function, you just wrote the str and the repr function, and you defined R1 is equal to rectangle of some value, and you printed the R1 wherein it printed this is an amazing function.
Correct.
So when we are just defining R1 is equal to rectangle of some value and trying to print R1, okay, so is it like it is just, how do we know that it is going to print the function which the line which is defined in str? Is it by default that we just say
Yes.
print it to the str?
Yeah, by default. Here we have to say repr. So R1 equals to rectangle of 10 and 20. Okay. Now I'm going to just hide these lines and run this. Okay, not getting it right. So to get the proper print, I need this to be enabled.
Okay, so this is kind of interlinked, and that is the default function. So whenever it is defined, that gets executed.
Exactly.
Okay, and in the init function, it's only for initialization of the values. We don't print or do any calculations there.
We can, but not recommended. We can write print statements here, print hello, for example. But the moment I define something, it's going to happen. Hello, you see that?
Right. So in this case, okay, so then the default function will be init, and that gets executed.
Yes.
Okay, thank you.
Karthik?
Based on what you mentioned, right, Rohan, is it fair to say that if A is B is true, A equal to B will always be true?
I didn't get what you say. What do you mean?
What I'm saying is, if like there are two types, right? If A is B, we mentioned that both of them are pointing to the same value.
Yeah.
So what I'm saying is, if A is B is true for something, then is it safe to say that A equal to B will always be true?
100%. Now, why is this important to understand? Let us say you're checking a value of B, okay? And B is supposed to be some dictionary value or some data set value. Now there you found a null, okay? And A, and this is something that caused a lot of error, it was supposed to point to a particular memory address, which was supposed to be moved here inside this dictionary and was pointing there, and that is also null. Now, when you say A equals to B here, it's going to come back as true, whereas both of them are doing different things. I wanted my A to be pointed here. That's why it's very important to make sure that you know that you are checking the value or you're checking the memory address. It's very important to understand.
But like why, when we discussed, right, you mentioned that when you are writing A equal to something, it's actually just pointing to the memory where that value is stored.
Correct.
So if that is already stored and then like later someone defines B equal to that thing, wouldn't both of them always point to the same thing? Like when can it happen that they won't?
Yes, answer is yes and no. Yes, if you are in the global space, right? You are here and null is stored here. But then if you assign a memory address, memory block, like we do in a class, in the class we store null somewhere over here, then pointing to this null and pointing to this null is different.
Got it.
These two are not the same nulls. All right, so that's all I think we have for today. Let me just check. Yes, one more thing. That's a simple thing, but anyways, let's go through it. Now we're going to look at some of the file things. So I can close this and I can close this also. And let's go and run terminal. So terminal is also up. Now we're going to write a few files, and I've already written anything, so we can call that I've already shown. Okay, I'll just show you one more thing. So here is one, and let me create new one. Let me call this main.py. Now I can import anything here, and I can then call anything dot mult, and I can say 1, 2, 3, and I can print this. So we can call one module from other module. So now I can call Python main.py. It's going to internally call anything, and that is going to calculate that function and return back. So that's how internally the Python is going to work for us. See if anything else is pending for today. So we discussed Python 101, we discussed 1 and 2 also, we discussed cursor, version control, and syntax, numpy and all. I'm not going to touch. Okay, so now we are open for questions. Any question do you have under the sun? We talk about global and local space. Is it any different in Python? It's not different, exactly same as it is in the other space also. In the global space, we have a lot of functions defined and we can use them. Local space, I can actually show some things. Actually, yeah, one thing that I would like you to notice, and that's very different from other programming languages. So for, okay, let me do this. We have not used the variable q today, okay? So def, and let's call this function gfunc. Q equals to 45 and gfunc print q, and run this, and if I now call q, it's going to come back and say q is not defined. Got it? Now let's say we have for in range 10. Range 10 is also iterable. Q is equals to I, and now we type q. We're going to say q gets a value. This is not true for C++. Whatever variables are defined in C++ internally of a for loop are internal to it, but here we get q outside available as well. There's one major difference that you need to understand from other parameters. But whatever is defined in function is a local space. It's always going to be there. And Okay, so we have this thing called global space where a parameter defined is accessible everywhere. Then we have this thing called local space where parameter defined is available here. What if something is not global and not local? What do you think we call that? If a parameter is not global or local, what do you think we call it? Call it non-local. Could we have called it anything else? Yes. Why is it called non-local? Let me give you an example. It's a very interesting example. So def, call this outer, I equals to 10, def, I equals to I plus 1. Turn, I is before is yes. See that? We just made a counter. So what are we doing here? These are very extreme. These are like high concepts. These are called decorators. And if you moment you see decorate in future, I hope you realize that we spoke about them. We made a function that returns a function, and it has a function inside it. And then we have this variable. This variable was assigned to some value and was used internally. And to use that variable, I have to tell inner that I'm using a non-local variable, and I added 1 to it, right? And then we assigned outer to func. Now outer returned the inner function, assigned it, and then went out to the memory. So it's gone. So what is func? Func is pointing to memory address where we have the inner function because it was passed, but it also has this 10. And the task of the inner function is to keep updating this 10. So this 10 is non-local. So we have a global space, we have a local space. Anything defined inside this would be local. Anything defined here will be global. So if I say, for example, k equals to 10, this is global. But then we have this space inside somewhere, this magical space. This is non-local also. Python is funny from that point of view, but pretty advanced and pretty functional if you actually start using it. All right, so session is formally over, but I'm still here in case you have any questions.
Rohan, just question on the cursor.
Yeah.
We are using cursor because it has integration with the Copilot. Is that the reason?
Okay. Copilot is something promoted and given by Windows. Cursor is a company which has a Cursor LLM themselves. And I think Cursor LLM is much better because internally they use Claude compared to the Copilot. Copilot is trying to catch up to Cursor. So you are looking at a state of art right now.
Okay. And it is available with the free version, which we are going to use.
Free version, yeah, you can use the 15-day version provided by Cursor. After that, we're going to use the Gemini LLM. That has its limitation, but that should be good for what we plan to do.
Okay.
Yes, I'll upload this and I'll share this. I will share directly on the queries. So I'll not be emailing this, but it's going to be on the queries Telegram link. Here's a queries link. Thank you. I'm not going to